Hi, good morning. Today we are going to learn about reflection of sound applications, Doppler effect and its applications. Reflection of sound waves is used to construct the devices like air trumpet, megaphone and soundboards. These three air trumpet, megaphone and soundboards are used in an auditorium. Air trumpet. Air trumpet is an application of reflection of sound device. It formerly used as a hearing aid for who are difficult in hearing. It was first used by sailors. It used to communicate long distances, then later used as a hearing aid. This air trumpet has two parts. One is a wide end, another is a narrow end. The sound waves received by wide end, that received sound again reflected into the narrow end. This helps to concentrating the sound. That sound enter into the eardrum to receive more intensity. This helps to hear clearly those who are difficult in hearing. These are the some of modern electronic hearing aids. Next is megaphone. Megaphone is a cone-shaped acoustic device. It's used to address a small gathering of people. It has two ends. One end is wide, other end is narrow. When a person speaks at the narrow end, the sound speech is concentrated by multiple reflection of walls. This helps the voice can be heard loudly and over long distances. Soundboard. Soundboard is a curved or concave reflecting surface. Soundboard placed in an auditorium behind the speaker. It used to improve the quality of sound. The sound waves incident on a soundboard and sent evenly towards the audience. This helps to improve the quality of sound heard by the audience. Next is Doppler effect and its applications. Have you ever heard police car or ambulance or fire engines cross and hear the siren? Does the siren change suddenly? Based on many observations, an Australian physicist, Doppler, proposed the theory called Doppler Effect in 1842. The whistle of fast-moving vehicles like train or fire engine appears to increase the pitch the vehicle approaches to the stationary observer or listener. The pitch appears to decrease the vehicle move away from the stationary observer or listener. What is source? A source, which is a vehicle or object that produces sound, called source. What is meant by observer or listener? Those who are heard the sound that produced by source called observer or listener. There is a relative motion between the source and listener. The frequency received by the listener is different from the original frequency produced by the source. Various possibilities of relative motion. The listener moves towards or away from the stationary source. The source moves towards or away from the stationary. Both the source or listener move towards or away from one another when both the source and listener are rest. The apparent change in frequency of sound caused by the relative motion between the source and the observer. It can be said in other words, either the source or listener is moving or both are moving. The observed frequency of sound is different from the frequency emitted by the source. The Doppler effect can be calculated in the formula f of o equal to f of s into v plus vo divided by v minus vs. Here f of o means frequency of observer, f of s means frequency of source, v means velocity of sound, vo means the velocity of moving observer, vs means the velocity of moving source. If the observer is moving toward the source, vo is positive. If the observer is moving away from the source, vo is negative. Then, if the source is moving towards the observer, vs is positive. If the source is moving away from the observer, vs is negative. Increase or decrease the distance between the source and the listener, we can hear different possible frequencies. For no Doppler effect. In some situations, we should not hear a Doppler effect, which means the frequency heard by the listener or observer will be the same frequency produced by the source. There are 4 conditions when source and the listener both are rest. Then the source and the listener move in same distance or constant distance. When the source and the listener are move in a perpendicular direction. Then source situated at the center, circle along the listener is moving. These are the 4 conditions we can't hear the Doppler effect.